Okay, here's a little micro lecture on the algebra of all the choice, really, not just quality choice, output choice 2 under transfer pricing. Let's begin with the basic model. So for the demand curve or the marginal benefit curve, we have this is the demand price. It is equal to A minus B of S times Q, and let's define the parameters. P, as I said, denotes the demand price. A is the demand choke price. If the price is above the choke price, then demand is 0. B of S is the absolute value of the slope of the demand, so there's a minus sign in front because demand is downward sloping. Q is the quantity purchased. And finally, S is an index of quality measured vertically. The higher S, the higher the quality. We're going to continue with the setup by now talking about the marginal cost curve. It has a similar equation, P equals C plus D of S times Q. Now P is the supply price, C is the supply choke price. If the price is below the supply choke price, supply is 0. D of S is the slope of supply, it is upward sloping. Q is the output produced, and as before, S is the index of quality measured vertically. So there's our setup. Let's talk about social surplus now, and here's the algebra of social surplus. So here's an exact formula. The social surplus is a trapezoid as we graphed in class. The height of the trapezoid is Q, the output. There are two different bases. One base is measured as the difference between the demand choke price A and the supply choke price C. So A minus C is one base. The other base is the difference between the demand price at Q, which is this, and the supply price at Q, which is this. You average the two bases. That's why we're dividing by 2 here. So that's the area of that trapezoid. If you do a little bit of algebra, clearing terms, you get this is A minus C minus the sum of B of S and D of S times Q over 2. So this is the algebraic formula for social surplus. And then, as I said in class today, we can partition social surplus into the consumer surplus and the producer surplus, depending upon whether the price is the demand price or the supply price. So our next part of this presentation will be doing the algebra of each of those partitionings. So here we will partition based on the demand price. Here's the social surplus formula I just figured out from the previous slide. Here's the demand price. That's the formula for the demand price. So now we're going to look at the consumer surplus. Consumer surplus in this case is the area of a triangle. The base, the height of the triangle is Q. The base of the triangle is the difference between the demand choke price and the demand price. So that difference gives the height of the triangle. And if you do the algebra, A minus A is 0, minus minus B is plus B. So this is B of S Q squared over 2. That is the formula for consumer surplus. Now, you could figure out the producer surplus by taking the social surplus up here and subtracting off the consumer surplus. We'll figure it out directly by looking at the area of a different trapezoid. Again, the height of that trapezoid is the output Q, and the base, there are two bases that we average. The first base has the difference between the demand price and the supply choke price. The second base has a difference between the demand price and the supply price. You average those, that's why we're dividing by 2. And if you clean this up, you have an A over here, an A over here, so that's 2A, and when we divide by 2, that's just A. Likewise, you have a minus C over here, and you have a minus C over here, so that's minus 2C. We divide by 2, so that's A minus C. And then the other terms, excuse me, we have a minus b of s in both places as well, b of s times q. So the same story is with that. The minus d of s term is only over here. There's nothing of a minus d of s type over here. So when I put those together, I have minus d of s times q over 2. That's the only place where we're dividing by 2 now. So that's the formula for the producer surplus. Now we're going to do the same sort of exercise, social surplus partition, but now we're going to use the supply price. So here's the same social surplus formula we've already had. The supply price is given over here. Now the consumer surplus is the harder one to compute, and it is a trapezoid. The height of that trapezoid is again Q. One of the bases is the difference between the demand choke price and the supply price. The other base is the difference between the demand price and the supply price. You average those two, and you get the average base times the height, and that's it. Now, this cleaning up of algebra was just like the cleaning up of algebra before. When we did it before, the producer surplus side had the Q over 2. Now it's, the D of S side had the Q over 2. Now it's the minus B of S part that has the Q over 2. So there's the formula for consumer surplus. Producer surplus is a triangle, and here's how you compute that triangle. The height is Q. The base is the difference between the supply price, which is C plus D of S times Q, and the supply choke price, which is C. So the C's cancel, and what you're left with is D of S times Q squared over 2. So that's the producer surplus, in this case, the area of that triangle. Okay, now we're going to do a little bit of calculus to figure out optimal output. And you can pause here at any time if you want to try to do these computations yourself. So we've done the social surplus. That's the formula for it. We're going to now maximize with respect to Q. And the way we do this in economics is we take the derivative of this expression with respect to Q and set that derivative equal to 0. So Q enters here and it enters here. And if you remember the derivative of the product rule, it's the first times the derivative of the second. So the derivative of the second here, it's Q over 2, and the coefficient is minus B of S plus D of S. So that's the first times the derivative of the second. And then it is the second times the derivative of the first. The derivative of Q with respect to Q is just 1, so that's the second part. So that's the derivative of social surplus with respect to Q. And now you can clean this up. You have the A minus C part over here. You have the minus B of S plus D of S over 2 part both times. And since it's over 2 and you've got it twice, now you've got it without the over 2 part over here. So that's the derivative. At the maximum, as I said, this derivative equals 0. And if you do the algebra of setting that equal to 0, you also get this. A minus B of S is equal, I'm bringing the C minus D of SQ to the other side, so that equals C plus D of SQ, which is saying at the social surplus maximum, the demand price and the supply price should be the same. This is the condition that we already knew. So that's the natural condition for maximizing with respect to output. Now we'll get to the calculation for maximizing with respect to quality. We have already this social surplus. We're going to use the same method. We're going to differentiate, but now we're going to differentiate with respect to S. Oh, it says differentiating with respect to Q, but it actually should say S here. So that's a typo here. We're differentiating with respect to S, and S enters here and here. B prime is the derivative of B with respect to S. D prime is the derivative of D with respect to S. So what you get is that this should equal 0. The derivative of social surplus with respect to S should equal 0. And that means that minus B prime plus D prime should equal 0. At the maximum of this function, its derivative is 0. So we are, if you will, choosing s to maximize b of s, maximize minus b of s plus d of s. And if you maximize the negative of the function, that is like minimizing the function. So we're at the same time minimizing b of s plus d of s. That's what maximizes social surplus in terms of quality choice. Okay, we're now going to do a similar exercise, but now do it for the producer surplus. So here's our expression for producer surplus that we've already computed. And again, it says differentiating with respect to Q, but it should be saying differentiating with respect to S. So I've got the same typo twice. Maybe next year I'll change this. So now we have S entering here, and the difference here is that the D term has a 1/2 multiplying it before both terms were multiplied by 1. So, and this should say the derivative of producer surplus with respect to S. We are differentiating. Oh, bad. Oh, I see. We are actually, I'm totally sorry. Let's pause here. Let me stay with this for a second, but I've read this wrong. We are actually choosing output here. So this Q and this Q are right. We're choosing Q output to maximize producer surplus. So these calculations are right, except what is written here, we have to again use the product rule. So it's the first times the derivative of the second. That's the first. Now Q enters over here on the B of S part with a coefficient of 1, and on the D of S part with a coefficient of 1/2. So it's minus B of S minus D of S over 2. That's the first times the derivative of the second. And then it's the second times the derivative of the first. That's the second. Derivative of the first with respect to Q is just 1. So we have these terms. We combine them, and we get this. So we are choosing Q here. This expression should equal 0 at the maximum. The derivative of producer surplus with respect to Q is 0, or in other words, and now I'm going to isolate the demand side part and the supply side part. So on the demand side part, I've got A minus 2BS times Q, and I'm bringing over the C and the D of S times Q to the other side. This is marginal revenue. This is marginal cost, or if you will, the supply price. So marginal revenue equals marginal cost is the condition for maximizing producer surplus, and we already knew that. Now we're going to try to maximize with respect to quality, and hopefully my typos don't exist here. So there's producer surplus again. We're going to differentiate with respect to S. Hooray, it says S. And so we're taking the derivative of producer surplus with respect to S. S enters into the B term over here and the D term over here. So there's the minus B prime of S times Q, and then it's minus D prime of S times Q over 2. And we're just going to isolate the terms that have the S in them. So it's minus B prime plus D prime over 2 times Q squared over 2. That's what the derivative of producer surplus is. At the optimum, this should be 0. And what that means is that since Q squared over 2 is positive, that means minus B prime plus D prime over 2 should be 0. So that should be 0. So S maximizes minus B of S plus D of S over 2 to maximize producer surplus, which means it minimizes the negative of that. S minimizes B of S plus D of S over 2. The last part of this exercise now is comparing socially optimal versus monopoly in terms of the quality choice. We already know in terms of the output choice, the monopoly output is less than the socially optimal output. How does the minimum of B of S plus D of S compared to the minimum of B of S plus D of S over 2. That's the question we're asking. And recall by our assumptions, B prime is negative, D prime is positive. So if S star is the optimal quality, socially optimal quality level, B prime of S star plus D prime of S star equals 0. And remember, this term over here is negative, this term is positive. So B prime of S star plus D prime of S star over 2, that's less than 0 because, if you will, I'm adding less of a positive than I was adding over here. And if this one added to 0, this one has to add to something less than 0. So that means the monopoly payoff function is still decreasing at S star. And if you want to get to the minimum for a decreasing function, you increase the value of S, so the monopoly quality level is higher than S star. That's what this shows. That's the conclusion we really wanted to get to.